hello. It has been a while, but we're doing the streaming thing again. Let me go link this in Reswitched, which I always forget to do before I start. Okay, that's linked now, and then I'll give people a couple minutes to filter in. But we are finally back to working on kernel stuff, which I'm very, very happy about. Because as much as I've enjoyed the months and months of other shit that I have had to do that was not working on the kernel, I have been wanting to work on the kernel. Hey, Simon. We are doing a thing where we give people a couple minutes to filter in. Hey, Mythos. Hey, John Jaded. Hey, Aurora. Yes, I am also very happy to be doing kernel stuff, John Jaded. Let me pull up the atmosphere repo. Hey, Tux. Oh, I should probably mention to Finks that I am streaming. So if I pull up the roadmap, it has been a while, but a lot of things have happened. So when I last was streaming, these were the three things that needed to get done, and these are all done now. Daybreak is a system update or homebrew that'll be releasing with the next atmosphere release that'll be out whenever XKYZ finishes fixing a bug. So yeah, no, the highest priority thing on my plate again has been Mesosphere, working on the kernel, and I have been doing that for the last little bit. And I did a bunch of work this week, but couldn't stream because I was not in a position to. And we're at a point where I can stream again. And right now the kernel is getting to debug active process on hardware. Hi, Psycho Megaleo. Hey, Kitlith. And in particular, if I pull up the code, atmosphere, stratosphere, PM, source PM main. We are getting to this point where to support older firmwares, Atmosphere's process manager needs to register all of the first processes with file system and with the service manager. And Nintendo provides no way to do this. So as a workaround, we get the list of processes, and then we call debugActiveProcess on all of them. And then we wait for the attached process event to get the program ID. And this lets us know what the program ID or title ID, whatever you want to call it, is of all of the internal processes. And so that is where Mesosphere is getting to on hardware. Yeah, no, this is a pretty early stream. It is a weekend. It's a Saturday, obviously. I don't know why I need to say that. And I will probably be streaming for about 4 hours-ish. And it will be however much I can get done in that time. I'm not thinking that we'll have any guests. So this will just be a working on kernel stuff and talking about kernel stuff stream. So, with that in mind, it's been 5 minutes-ish. I will probably just get started. So just so that you guys can see what it looks like when I work on stuff, let me eject this. I'm using Hec8 UMS stuff. And then let me reboot. And the host is still actually controlling the PC. Or the host PC is still actually controlling the switch. So let's see how this goes. I just hit run PSA primary, and it should give nice output. It'll output a lot of stuff because it is getting really, really far. Hey, thanks. Yeah, so this is what it looks like when I run it on hardware right now. And it's getting really far. FS or file system or whatever you want to call it is getting through all of its hardware in it, and the bootsys module is stalled waiting for file system stuff. And I'm really, really happy that it's getting so far. But with that in mind, the next thing that we need to do is we need to implement debugActiveProcess. So let's pull up the database, which I had it open here because I knew that I would be working on it. None of the debugging stuff is implemented at all. It's all placeholder right now. So, implementing a service call, system call, whatever you want to call it. Let me function debugActiveProcess outputs handle and takes in a process ID. Still don't know why you're surprised by my voice. My voice has not changed in the year that I've been streaming. We want to hook it up to both the 64 and the 64 from 32 ABIs. So what is the kernel doing? The first thing the kernel is doing is calling get process from ID. And I think I implemented this not badly because it's implemented correctly, but I think if I go to my implementation of this, get process from ID, which I implemented very recently. Yeah, I had it return a K process, but we can see here that whenever the scope ends, this is going to get decrefed, and there is actually an incref in here when it opens. So a more accurate way to do it would be to return a K-scoped auto object. So let's actually change that. K-scoped auto objects, K process. Because if we just return a scoped reference, we don't need to care about making sure that we handle it properly, and everything will just be nice. And now we just do return process. Although this allows an open failure, which isn't normally a thing that can happen. I think it's fine. Yeah. Okay. Yeah, if open fails, that is if the stirx fails, it will fall through into here and continue looping, and it'll eventually return null pointer. So actually, if we want to keep that behavior, we need to not have it be a scoped auto object. So that's me just being wrong right off the bat. Okay. So this is really like a scoped auto object, but it's not because the open is allowed to fail, which is not true for almost every place where open is used in the kernel. So let's get back to where we were, and let's say from its ID, say key process. This is really the target process. Let's call process. Get process. Is it by ID or with ID? I think it's probably by ID. From ID. Better off having Muppet voices for everyone, so the expectations are low. I'm glad that I can meet low expectations. That's always the dream. Unless the process is not null pointer. It's probably invalid process ID. Okay. And then on scope exit. Yeah, so thanks. I was going to change it to an autoscope thing, but then I realized that this is actually allowed to fail. Kind of unique among open statements in the kernel. This only returns the process if opening succeeds. And opening should always succeed, but given Nintendo has this behavior, it seems probably wisest to keep it. And yeah, thanks. If the store exclusive fails, instead of looping to do it, oh, actually, never mind. I guess this is a while loop. Okay, never mind. You're right. Nah, you're totally right. Cool. We are doing the thing. That's changing our minds twice in one go. Excellent. Okay. That is an improvement. Process. Okay, no, that's definitely an improvement. Excellent. Excellent, excellent. Okay. And then the next thing that it does is once it gets the process, is it checks whether or not the process can be debugged. Like, is debugging the process permitted? And if it is not, then it checks whether or not the current process is allowed to force debugging. And if it's not, then it returns invalid state. This is like, check that the debugging is allowed. If process dot is debug permitted, the way that it usually does this is permitted debug unless current process dot is force debug. Okay, now's where we actually make sure that our processes can do this. Yeah, I wonder so too sometimes. Interrupt. Yeah. Yeah, no, the naming is like one of my favorite things about working on this. This is because I know Nintendo uses these crazy names. Okay, let's go to K capabilities. And then debug flags will be somewhere in here. Oh, yeah, debug capabilities. Then let's add these. Expert rule is permitted debug. Turn this debug capabilities. Where is this? Debug flags. And we want allow debug and force debug. Okay. And then let's add can force debug. Cool, okay. So that should take care of checking that. And then the next thing that it does is it checks if the current process is equal to the debug process. And actually, this was a bug on older kernels, I think less than 6.0 maybe, where if you tried to debug yourself, the console would hang forever. Like, this check wasn't here, so it would debug your process, which would pause you, which would mean that you couldn't continue yourself, which is very funny. Unless process get pointer unsafe is not equal to get current process pointer SVC result invalid state. That should be that. Hey, Big Daddy UK 666, your username is still very funny. And then it gets the handle table and it creates a debug. Okay. debug, because this is creating a new KDebug object. Scoped auto object debug is KDebug create, which we haven't written yet, but we will. And then it's probably out of resource, but let's check. If it's null, yeah, it's out of resource. Unless debug is not null, it's all out of resource. And then it's going to call debug initialize. And this is not checked, so probably it cannot fail. And then it is registering the debug with the list. Hey, Thog. Hey, I don't know how to pronounce your name. F-I-L-Y-X, Felix, maybe? Really bad mispronunciation of Felix, maybe? We want to attach to the target process. Then we want to add it to the handle table. So that is all straightforward. Okay. Let's fix that typo. And then add to the handle table. Okay, I think that is a structurally correct implementation of DebugActiveProcess, but the problem here will be that it won't compile. We will start trying to compile it, and we will find that it's going to complain. Really? Is it not compiling libmesosphere? That's going to be really annoying if I have to do like the cd and make etc. But I thought if I go to the make file that I had fixed that. If I go here, the precompiled headers are mesosphere.hpp. Depends, GCHSD. So that should be a thing. Sphere. So this isn't a shared folder. This actually really exists within the VM, which is why I'm confused. Whatever. If I have to like do a longer copy paste statement that like does a make clean every time, that's not the end of the world. It's a little annoying, but it is far from the end of the world. Yeah, there we go. Okay. That is not a problem. Oh. Okay. It is difficult to return one from there. Okay. So that is kind of a problem. Maybe that was why I did this. So thanks. Returning a scoped auto object from here is kind of a problem because the kprocess definition isn't done yet. Which is very funny, to be clear. But yeah, I don't think I can instantiate kscoped auto objects with kprocess from here. Okay, so we'll be back to process. That's a shame. That's now 3 times I've changed this. Yeah. Ah, well. It's not the worst thing. Okay. That's that. What I could do, I could enforce at the like client site that it's a scoped auto object by just not doing the open here. Like if I do every time that this is used, k-scoped auto object equals, but I'd kind of rather have the open be in here if I'm not going to do that. So I guess I will just live with it. Oh well. Not the end of the world. I agree, it's a little painful. Where else is this used? Alright, process. That's actually simpler. And this is also simpler. Okay. That should fix that. This is going to fail to compile because we don't have like KDebug create defined or anything. Yeah, that tracks. Yeah. So invalid process ID. Okay. What is that result actually called? Atmosphere, libraries, let vapors include vapors, SVC results. Or I guess it's results, SVC results. Process. Guess we don't have it at all. Okay. Invalid process ID is 40801. Do I want to try and do this in my head? I do not. $517. Okay. Cool, so I'll take care of that. This, we need to implement KDebug initialize. We need to implement KDebug attach. And also KDebug is abstract because it doesn't implement k-synchronization object is signaled. And none of that is going to be particularly bad to do. Let's do a compile and make sure that that resolves the invalid process ID issue, and then we will get to actually implementing the stuff that we need to implement for it to work. Yeah, okay. It is signaled, yeah, same stuff. Attach, initialize. I mean, invalid process ID. Did I make a typo? Oh, right. Right. I forget that. So the other thing that I need to do is mesosphere has a namespace that's kern SVC, and I like alias all of the results into it by hand, which yes is gross, but serves its purpose. Result invalid process ID. Okay, so I'll take care of that then. That will take care of that. Okay, so is signaled should actually, I think, be inside KDebug base, because KDebug base is what implements the synchronization object, and because detecting signaling is not architecturally specific. Yes? Yes, okay. That's happier now. Public. So KDebug base has no constructor and destructor, I think, because all of the actual like implementation logic is in KDebug. So it should just be KDebug base and virtual KDebug base. What is the definition from sync object? case synchronization object. It is a virtual bool is signaled const. Okay. Override. And the other thing that I think should be a KDebug base method is attach, because attaching shouldn't have anything to do with architecturally specific stuff. And that should be results attach kprocess. Okay. Oh, and the other thing that I think I need to do before I do anything else is this is going to need like a post destroy definition. They do have a KDebug base tux. You will find that certain methods that you would call KDebug access no KDebug members except through like inherited member functions. They have a KDebug base for everything that's not architecturally specific. Grep post destroy. Oh, right. Yeah, static void post destroy. Okay. I'm pretty sure it doesn't have anything interesting in post destroy. Let's actually check that. What is the type definition for debug? Yeah. I like didn't really tag debug versus debug base here, but we'll roll with it. If I go to the vtable, finalize, what is it, override on final synchronization. Ooh, is that going to need to be overridden? It is. Okay. So let's add that here too. On finalize synchronization. Yeah, the xargs grep thing is just such a force of habit, I don't think about it. Get post finalize argument is 0. Yeah, post finalize is going to be empty. KDebug destroy. Where's this referenced? All right, it's via vtable. KDebug. Yeah, I am pretty confident about that. If it is a problem, we will deal with it later. Yeah. Okay. There's nothing in the destructor. Yeah, no, the xargs grep thing is just total force of habit because I'm usually grepping through all of Atmosphere and not like one folder. Yeah, that's probably wise. Okay, so that's that. And then for KDebug, we're gonna need initialize. We're also probably gonna need constructor-destructor pairs. Actually, let me add like the member variables and stuff. That is something that I should do now. Okay, it's going to have a list of event infos. It's going to have flags for continue. It's going to have the process that it's doing. It's going to have a light lock, and it's going to have a process state for the state of the process before it was being debugged. That's all easy enough. Although these are probably debug base members, aren't they? I think that is hard to say the best of times. Yeah, no, none of this is architectural specific, so it'll be debug base. Okay. So I guess we're going to continue doing stuff in here. Do I have k event info? I probably do. I do. Great. And of course, I don't really have anything in here. But I do have it that it inherits from base traits, so that's great. Let's do using debug event list. This will need to include k event info. Till list of base traits. That protected actually. It's probably protected. And then what are the members here? key event list, the continue flags, the process, the mutex, and the old state. Okay. Debug event list. Event list, you need to continue flags, k process, process. And is process state a member of k process? Probably. I just need to look if it's k process state. It is. So actually, this probably needs to include k process, which should be fine. Which should actually be fine, I think. And then it won't need the forward declare. It'll just be a process, process state, old process state. Double check that one more time because I am a lot of things, but good at writing C++. It's not one of them. Okay, so it's just k process state. That's what I called that. State, old process state. Okay, and then structure. Process old process state. Cool. Okay, that should be fine then. Not good at C++. Write some mini compiler in C++ templates. Yeah, I'm good at certain things in C++ and not so good at other things in C++. Okay, so what does kprocess initialize actually look like? Or kdebug initialize, rather. Nice, that totally tracks. I guess that's gonna be debug based too. Dangerous, but it's what Nintendo does. Okay, let's go ahead and start implementing this. Mangling by hand is, yeah, it's super reasonable to do. People who don't want to mangle by hand are just scared, I think. Probably. Source, okay, now let's copy paste some random file. Kern k base. Want to initialize, attach on final synchronization, and is signaled. And let's see. Yeah, no, mangling by hand is so worth it. The output you get from mangling by hand on like IDA, for example, is fantastic. For those who have not seen me work on kernel code before, I have this macro mesosphere unimplemented. And what it does is it is basically just a panic statement that says, LOL, you need to implement this. And this will let all of this compile. And then whenever I actually hit this at runtime, it will like print out a panic statement. So this is very useful for quickly getting stuff into a state where it compiles, even if it's not correct. But this is easy. This is very easy. This process is I don't save x12 to x17 when entering an SVC. If I don't save it right now, I will edit the kernel SVC stubs to save it when entering an SVC, because one of the big things that I want in Mesosphere is proper debugging. I think you're right about that. And I think that we will fix it whenever needed. I'm very, very happy to do that. This looks like a big method that I'm going to want to implement later and not now. Is signaled. This looks significantly simpler, so we will actually probably, I think, do that now. Okay, so what is signaled do? First, it locks the scheduler mutex. And then it, okay, if it gets the scheduler mutex, it looks at the event info list and it checks whether or not, probably these are the same. Yeah, that makes sense. Check anything else. Okay. So we are signaled if there is anything in the event queue that is if the tail and the head are not the same, or if there is no process attached, because if there's no process it will return 1, or if the process is terminated, which makes sense. Okay. So this is going to be scope scheduler mock cell. Return this list dot empty. For this process is the pointer, or this process is terminated. Let me check K process. Yeah, okay. Cool, and that will take care of that. Okay, this one I think we're definitely going to want to implement later. I can implement this now if we want. Would we rather that I just like bite the bullet and implement on finalized synchronization now? We don't have to do it until later, probably. Sure, it's not actually that bad. Debug get process. No, that seems like a pain. We can do this later. We can do this later. Okay, what does attach do? Attach is going to be a big one, but that's okay. Because attach is one of the ones that we just can't actually avoid doing. And the first thing it's going to do is it's going to lock the process mutex. And the processes list mutex. That's interesting. Okay. So it's going to lock the process mutex, it's going to lock the process list mutex, it is going to lock the mutex for this. That's 3 locks in a row. It's going to lock the scheduler mutex. It's going to check whether or not it is already debugged, which makes sense. Although, is that really a kernel panic? That would surprise me. It's going to check whether or not the process's state allows for it to debugged. It's going to register this as the process's debug object. It's going to allocate a new event info for the attached process event, which is the one that we care about anyway. It's going to get like the JIT debug info. It's going to notify it. Yeah, no, like the thing about this is that this is like going to be literally all inlined, so it doesn't really matter. Okay, this is gonna be not so bad, it looks like. Okay. So, first thing to do, process shouldn't be null. Unlocking a bunch of mutexes. So let's do that in a scope. Okay, what mutexes do we unlock in each order? There are like 3 of them. The first thing that it's going to do is lock state mutex. What do I call the function that gets the state mutex? Really need to bring kprocess over here since it's like in use. State mutex. Get state lock, get list lock. Okay. First thing it does is it locks the state lock. Inline fate party. Then it locks the list lock. Then it's going to acquire the mutex for this. And then it's going to, once it's done with all of that, it's also going to get a scheduler lock. This is like a lot of locks. Yeah, no, that is a lot of locks. And then this is debug suspended this problem, which is the maximum state. That makes sense. Okay, so this is probably a list of states where it is allowed for us to debug. 0xd. Can I get this in binary? No, that's fine. B is 0b1101. Okay, so that's if state is 1. Our state is 0, 2, or 3. What are those states? State needs to be created, running, or crashed. It can't be attached, it can't be terminated, and it can't be debug braked. So that makes sense. And if it is, what result does it return? Okay, so if it is created, that's interesting. If it is terminating or terminated, because that's what this is going to be, or if it is like created attached, it's going to return terminated. Weird. Oh wait, equals 0. Okay. Turns busy for the other ones. So that's actually created attached and then running attached maybe. 0, 1, 2, 3, 4, 5, 6, 7. Okay, never mind. I inverted that. This is if not get attached, unattached, debug break, if terminating. Okay, and then the other ones are going to return result busy, which makes sense. Okay. Where were we? We're up here. Oh, and actually I missed this. If the process has an object attached to it, then it's going to return busy. Okay. And let's add that. Okay, got that now. And then we want to switch on the state. Hey, Junior Gamer. You're welcome. I'm glad you enjoyed the things that I do. Get state. Let's check that. Yep. As a figure, not done a lot of stuff with K process, so it's not that surprising that I need like a getter for it. Okay, and then switch state. Let's copy all of these. And the kernel panic will just be a I think it's mesosphere. There might be an AMS unreachable default case, actually. Let me check that. If I go to kernel panic. Nope, it's mesosphere unreachable default case. Great, okay. I'm gonna hit save on this because the purple icon makes me think it's what I'm currently editing. Yeah, there's a lot of macroing, but it is all very useful macroing, so I am, pretty happy with it overall. So terminating and terminated are going to return results. I think it's like process terminated. Where was this? Yeah. And then created attached, running attached, and debug suspended. We're going to turn SvC result busy. And created, running, and crashed are allowed to debug. So these will break. Should only go there. Okay. And then what happens when we are succeeding? Go back to the success case. So this sets the process and opens a reference to the process, which makes sense. That's fine. I guess I'm gonna better, I think, to not have this process and process be aliases of each other. That is the source of issues when that happens. Okay. And then what's next? Old process state is set attached object. Okay. Should really better name for that is like set debug object, because that's what attaching is for. Great. And this makes sense. That's pretty straightforward. Yeah, if it's not already debug braked, then it is going to be check if it's created, otherwise it's debug suspended, otherwise it's created attached, and then it's going to signal. So let's add this here. So debug object, and then this is going to be, all right. Should I say can a K debug or avoid? I guess it's avoid. And this actually returns a kprocess state. Returns rolled state. Wait, and then the state is it doesn't necessarily mean that. It is indicative of that, but this is also the only place where it's called. And I am not trying to match them at that level. I am pretty happy to put a function like this in the header. Although I guess, yeah, you're probably right. This should go in the CPP. I'll move it to the CPP after. You're probably right about that. Right. This is signaled as true. Okay. You're right about that. Thank you, thanks. Let me go here to kprocess. Let me take all of this and basically just paste it down in here. And then this can go like that. Cool. Okay. So that takes care of that. Then what else? What else is there to do? This is going to create like a new event. And type is attached process. And it's going to like enqueue the event. And that's probably a function on its own. Do let's push events, and what is the enum on that? Atmosphere libraries. Vapors include vapors SVC. SVC types common. Really need to get this over here. Attach process. Okay, cool. And I guess actually this doesn't need to be a to-do. I can just add it to the header. Nice. Void. pushing a debug event likely to be public or private? I think it's probably pretty likely to be private. Yeah. Oh no, wait, that's going to be the enqueue because you already created one. We're also going to want to push debug event. That's going to be const. No, wait, it's an enum. It doesn't need to be const. So what is this going to take in? Event type debug process. Let me see. This is like the shared push function for all of these places, where it's going to take in parameters, etc., etc. Okay. Exit process. How many parameters can this take? Did I just copy paste debug event underscore debug event? No, probably. I'm sure that I did. Yeah. Nice. Thank you. Yep. Thank you. Okay. I think that the maximum number of parameters that it can take is 5. Let me check. I think there's a definition for that in process. Yeah, exception type. Event type, exception type, and then 4 parameters. That's 5. Okay. Debug, push debug event. Debug events. Events, and then that is probably as flexible as we can make it. Cool. Let's add these. Debug events. Okay, so that should compile now. Let's get back up to attach. Okay. You mostly just missed me skeletoning the function for adding debug events, which this is all just super inlined, which is par for the course with kernel code, because they inline stuff really aggressively. And then it's going to get the thread list. Then for each thread in the list, it is going to request a suspension with, this is like a suspend type for debugging. It's going to check the state, which I think 0 and 1 are runnable and waiting respectively, which I should actually check. Kern k thread should be thread suspend type is debug, and yeah, it's checking waiting or runnable, because it's -1 is less than or equal to 1, so it's 1 or 2, waiting or runnable. And then if it is waiting or runnable, it breaks and it goes here, and then it's going to create a event for attaching to the thread, which makes sense. And then it is going to call get JIT info for whatever the JIT debug is, push the info for that, and then is going to add an exception event for attaching to the process, which makes sense, and then it is going to notify available. Okay, so that is actually all pretty straightforward. Hey, Tenebrio. Yeah, no, it has been it's been a long while since I actually did any streaming. I've just been super busy, which is natural, I think. Okay, and for each thread in the process, we want to send a request to suspend it, and if its state is correct, send the event, which makes sense. Okay, so let's see. What did I call the like request suspend function? There it is. For each thread, I want to do suspend kthread suspend type debug. And I think that's going to be doing masking, so it's not get state raw. Thread state. Thread state runnable, or state is kthread. Thread state waiting. Great. Then we want to generate the event. Although actually we are marking that it's attached first. Yep. And what are the parameters for this? It's the thread's ID, it's the thread's TLS address, and it is the thread's entry point. Okay. So how do I get all of those things from a thread? Well, obviously, get ID and then cool, get thread local region address. And then we want the entry point. Is that a UN pointer T or a K process address? It's probably a UN pointer T, but yeah, it is. Thanks. Entry point capital P or entry point lowercase p? Okay, and that should take care of the process stuff. Although also get set debug attached. Debug attached. Let's add that like right here. Okay, so that should take care of that entirely. And then we want to get the GetDebug info and enqueue that if there is anything. We want to send an event for the exception occurring. And this is actually not a debug event here. This is a like debug exception type, which, yeah, it's annoying, but it's a different thing. Let's see, what is that actually called here? It is debug exception. Really? Debug event attached process. Debugger attached, probably. Yeah, that's 4 for both of them. Exception. And then it notifies available. Hey, Dubs. And actually, notify available, we can just do this. That's fine. I think I'll change it in the other place where I did that in process too. It's kind of better. Yeah, no, it's never too late. I'll be doing this for like another 3 hours-ish, so no need to worry about that. No need to worry about that. IDA has my database for the 10.x Nintendo Switch kernel, Mr. Edie makes. I am re-implementing the kernel in C++, and the IDA database is my reference for how to make sure that my code is correct. Turtle asks, have you ever really burnt yourself out while working on Atmosphere? To which the answer is obviously going to be yes, as should really not surprise you. But let me let this stand for itself. If I go to Atmosphere, Insights, and like code frequency, you can see that there are periods of really high productivity followed by lulls, and I would say that the lulls are periods where I am like a little burnt out on writing Atmosphere code. I mean, the real answer to that question is just, I've never really gotten burnt out on writing Atmosphere. I love writing Atmosphere, but I do get burnt out on programming a little bit, and so there will often be like 2 weeks or so where I am crazy productive, and then weeks where I am not so productive. Turtle asks, how much coffee, tea do you wind up drinking to stay awake? Not very much. I drink a lot of green tea. Like I drink Yamamoto Yama, usually is Genmai Cha, as a substitute for water a lot of the time. I mean, I drink water, but I like have tea with meals, etc. But tea's not that much caffeine, so I just mostly don't. And the sane way to do this, the sane way to do this is going to be info is event 0, param1, param2, param3, param4. Create event info. Winner. I don't drink matcha, to be clear. I just drink tea. Cool, that should actually be all of push debug event, but then we're gonna need to do the, create debug events. I think for this, we're not going to want the defaults because this is an internal function. Yeah. No, I actually have like very little caffeine for how much consciousness I do. But it works out pretty well. Okay, so we're gonna want to make one for creating the event. Allocate a new event. Yeah, no, the my sleep cycle has been pretty constant for a very long time. Like, it's just what it is. Yes, you are correct about that. Thanks. Thank you. Silly. But yeah, Aurora, my need for sleep has been pretty constant. Okay, it also includes a thread ID. Okay, that's fine. Let's probably just get current thread. ID, probably. Yep. Okay. And then let's, this is gonna be like a switch on the type of event info. Almost certainly. So let's go ahead and, yeah, I guess it's a bit of an accent, isn't it? I don't think about it being an accent, but I guess that it is. Yeah, so this is like invoking getThreadID even though it's not being used, which is how we can tell that it's a parameter, which is very funny because this is a virtual function and so the compiler can't elide it. Here's next, that's fine. Flags, what are the flags here? It'll be like in types common. Ooh, is this gonna be an enum that I'm gonna need to add? I think it might be. Ooh, I don't have this in here, and I apparently don't have this in here. So I'm gonna need to do this flag stuff later. I will probably do that after the stream or at some point in the next week. I'll just use constants for now and mark them with to do. I'm kind of too lazy to figure out this enum right this second. Also, he says in things that he should have done like 30 minutes ago, we should probably make sure that KEventInfo is a real thing and not a fake thing. That's very funny. Yeah, we are gonna want KEventInfo to be a thing that exists. And I really should have done this like 30 minutes ago before we started actually trying to do things. Man, that's funny. KEventInfo, so that's the intrusive list base node. And then the event type, the thread ID, flags is attached. Okay, this is all mostly really straightforward. It's just going to be this union that's going to be a huge pain. Okay. And this is a struct, not a class, so we don't really need to worry about anything being private. I think this just gets acted on directly because it gets converted to an SVC event info. So let's go ahead and do this. Event, and then it's a U32 thread ID, even though thread IDs are 64-bit. And then flags bool is attached. Bool continue flag. Bool ignore continue. Bool close once. And then I'm going to need to define all of these unions, which is going to be a little annoying, but shouldn't be like literally the worst. So let's see. Also, thread. Union. Event info, probably. Union. How do I want to do this? I need to define the actual structure types. Okay, an event info union is a info for create thread, exit process, exit thread, exception, and syscall. Struct info thread, struct info exit process, struct info exit thread, struct info exception, struct info on system call. And let's do info create thread, info exit process, exit process, exit thread. Okay. Let's be info union. Cool. What goes in each of these? Create thread has a thread ID, a TLS address, and an entry point. That's probably you input it to. Exit process is going to be like an exit reason. Yeah, exit thread and exit that are both just reasons. Do we have these in here? Thread exit reason, yeah we do. And process exit reason, okay. Thread exit reason and process exit reason. Yeah, you're right. This can be an anonymous one. We don't need info union to be a real type, but the other ones I think should be real. What does exception have? Debug exception, the count, address, and data. Okay. What is the name for the debug exception enum? Debug exception, cool. this will be assigned integer. Cool. And then what else is there? System call, which takes in a tick, and a system call number. Okay. So it's going to be 6014. Cool. Is there literally anything else that we need here since this is all public? Debug reserved, which is definitely not a real thing. So then we can do explicit event info. Doesn't need to be const expr. And I know this is no destructor. So what does it clear on construction? Event info, it clears attached and continue flag, and ignore continue. Okay, also it initializes the base node. So let's do attached, continue, flag, or continue. Okay. That should be a correct-ish, it doesn't need to be context for blasphemy. Yeah, you know. This kind of thing, I don't see any value to const expr because unlike kthread or kprocess, I don't care about trying to do things like compile time for static assertions with this. So we can just let it be the nice and lazy non-const expr way of doing things. So we attach process. What happens here? Creates a thing. It sets the type to attach process. That's actually a keyword, isn't it? And so that's actually probably setting something else too. What is it doing? Thread ID. Okay, so it's clearing thread ID, it's setting the event type, and it's setting the flags to 1. Does it do that everywhere? Let's find out. Event type. It looks like it sets the thread ID here, but then it got a thread ID. Okay, if it sets the thread ID when it receives it, and clears it to 0 otherwise, it's going to do that unconditionally. Yeah. Keyword here where it doesn't have a thread ID. Okay. That makes sense. That makes sense. Okay. So we want to create the thread ID. Set fields, info. Is it event or event type? What did I call that? Event. Events, info, thread ID 0, and info flags 1, 2, enum this SvC. Yeah, it's a little annoying, thanks, but you get so used to it. I don't even think about that. Okay, let's get the types of event again. Oh wait, what am I doing? Okay. In the attach process case, it doesn't do anything. Because attach process doesn't have any info. What about in attached thread, which will be down here? It's going to set the thread ID, and then it is going to set all of the like create thread stuff. Which is totally fine. Okay. Let's check that. Yep. So we have thread ID, TLS address, and entry point. And this is info, create thread. Okay. Oh no, wait, this is gonna be param 0. Because thread ID is the current thread's ID. Let me actually rename this so it doesn't confuse me later. No, and this is going to be param 0. What is this even used for? I'm sure some type uses it. Night Tux. I'm glad you were able to make any of it, since I know that the timing is harder for you being in Europe. Sometime in the next couple of weeks, I will probably try to do a stream earlier in the day, Pacific time, so that you can make more of it, since I know that the kernel is very much what you were interested in. This is 1. Cool, and then what else is there? JIT-info is done directly. And in the exception case, it's going to be complicated, so let's process debug event, sure. It's not really what I want to do. On exit process, this is a event info. Okay, so there we go. This is going to be the exit process event. Exit process. Select union field. Exit process. Reason is 0. That's fascinating. But okay. It clears the flags at least. This is probably inlines. It's probably a parameter. Yeah, that'll be a parameter. Then terminate process. Select union field. Yeah, okay. That's a parameter then. Break process, exception. Yeah, okay. It's its own thing. Okay. And why am I looking at inlined versions of it when there is, of course, a not inlined version of it? Okay, well, good news, everyone. Implementing this just got a lot easier. Awesome. Okay. Well, on the bright side, it looks like I was doing an okay job. Fuck, that's really funny. Me goes to a bunch of effort to try to implement stuff from a from multiple inline versions. This is just explicit about it. Okay. Also, it looks like exit process clears the thread ID for no reason, even though it's cleared up above. I would not have put that in there without this, so that's fun too. Yeah, Aurora, this is going to be inlining it in the cases where inlining it leads to a significant reduction in code size, which makes sense, because if this is known ahead of time, then the function is much simpler. Okay, that's... fuck, that's so funny. Okay, well, this just got really easy. Yeah, I mean, it looks like we were mostly correct anyway, but this should make stuff even easier. I guess the event is kind of an implicit parameter 0, but that's fine. Okay, so exit process. This is going to do info.exit process. Reason. Static cast SVC process. Exit reason. Param 0. And info ID 0. Info 0. Also, I apologize as always for the railroad noises. I continue to live near a railroad. Yeah, I'm kind of thinking that too, Finks. I'll think about it. That's something to do a little bit down the line, I think. Exit thread. Thread, exit, reason. Where does it even get used? Current thread ID. Oh, right, that's an exception. Okay. Thread ID is param1. And this will be param1. Okay. Then set the thread ID. Current thread ID. And we're going to do switch. And this looks pretty straightforward, all things considered. So what do we want to do here? Let's get the enum in. And the default just breaks, yes, that's fine. We don't need like an explicit default. So undefined instruction, breakpoints, and undefined system call. All basically set the TLS address and the entry point to this. So let's do that. System call. Info.exception. All right, alt Y. Yeah, okay. And I think I just called this exception address. Yes, I did. Great. Address is one. Cool, so that takes care of those cases. And then what does instruction data abort do? It looks like instruction abort isn't in here, and data abort isn't in here, and alignment fault isn't in here. So those must all fall under the default. So let's move down here, the default. And the default case will just be to set the address to parameter 1. Okay. And everything else is going to have its own. I think memory system error has its own, debugger break has its own, user break has its own, and debugger attached has its own. Okay. Debugger attached clears the thread ID to 0. And sets the exception address to 0. User break sets the exception count to 3. Oh, I guess this is really like a data count, isn't it? Data count. Better name for it. That is a much better name for it. So, okay, where were we? User break. Did I do that right? Okay. User break is going to set the data count to 3 and then name I guess this is generic. I really wish that I had not offset all of these by 1 because it's making it hard to reason about it, but that's fine, I can deal with it. I am not incompetent. The exception address is still there, and then 0, 1, 2 will be parameters 3 and 4. And then debugger break is going to be much the same. But then it's also going to clear the address and the thread ID. Oh, actually, this is going to be 1, 2, 3, 4. I could rename them in IDA, but I don't think I will. That's quite a bit nicer, I think, aligning them like that. And memory system error just sets the address to 0. Okay. I believe that that is that. That should be a correct, assuming it compiles, implementation of yeah. Should be a correct implementation of create debug event. And then we need to do the logic for enqueuing at event info. Queue event info, which I expect is very simple. Yeah, no, this is basically just going to be lock the scheduler and push, which should be like surprising to basically nobody. Okay. Scheduler lock, and then this is going to push it. Push to the front. And I'm pretty sure that this is literally just a push operation. Where? Oh, the cases? It's because I have these scopes. If that's what you're asking. Yeah, this is just the case. Yeah, okay. So the previous is next, becomes the head, which means it's at the back. Okay. I think that should all be good-ish, good enough that I'm going to try to compile it. And it will fail. I am sure it will fail, but we will see where it fails. Intrusive list base traits. Got it. Okay, what next? This is always the fun part where I see all of the mistakes that I made while writing code that makes sense in my head, but is not real C++ code. Okay. Get thread list doesn't exist. That makes sense. Get debug info doesn't exist. And I typed in param0. Version from u1 pointer t to debug exception. Oh, okay, that just needs a cast. Cool. When I type make, it should complain about thread list and get debug info. But that at least shouldn't be too bad. Yeah, this should literally just be returning the thread list, I think. Assuming that it is... yeah, no, actually that should be very straightforward. Okay. Let's add this here. Let's check that by going back to attach for a bit. Process thread list, which is 4368. Let's just make sure that we're accessing the right list variable. Just it's right before the shared memory list, and it's right after the exception thread. And this is right after the exception thread and right before the shared memory list. Okay, great. So that is very nice and easy. But the JIT debug stuff is probably going to be a little more complicated. So let's look at this. Okay, that makes sense. I guess create event info is going to need to be public. And even more so, it's going to need to be static. Did this not access this anywhere? It does not. Okay. Great. Things you learn. Static. Great. Put this down to the bottom. Put this to-do placeholder in here where methods are going. And then I guess JIT debug info will actually be very simple, relatively speaking then. Okay, process. And I guess this will need to do what we did last time, which is info. That's what we called it. Get JIT debug info. Okay, that's fine. let's get JDebug info. So if this is JDebug, return that. Otherwise, we return null pointer. JDebug pointer. Okay. Debug event. Event 5 parameters thread ID. This is event 5 parameters thread ID. Great. And this is where people will complain at me, but I don't have an issue with long lines for this kind of thing. Cool. Yeah. And then push debug event can just do create debug event because it's not actually acting on this. Okay. Yeah, I mean, I guess calling myself out on it brings attention to it that might not have been put on it otherwise. But, you know, I'm a believer in being straightforward about these kinds of things. Okay, where are we complaining? Current SvcDebug. Great. Candidates. Specs and arguments. Did I not give KDebug a constructor? That's classic. Okay, so I'm literally just missing a constructor for KDebug, which I think won't even do anything, or at least like it shouldn't. Yeah, because KDebug base has no constructor or destructor, and KDebug will have no additional members, so that's literally just going to be classic. Explicit KDebug. Virtual KDebug. Okay, this might compile now. Maybe. Oh man, is it gonna compile? I'm like actually connect my switch via Hecate. That would be an intelligent thing to do right now while it's compiling. Linking the kernel takes like 30 seconds, so we've got plenty of time. Okay, it's connected now. Yeah, no, I'm also excited to test stuff. So if we did it right, it should all succeed, and then it will complain and say that PM... Do I still have PM main open? I probably do. I don't. Okay, let me open that. So, if we did everything right, then the invocation to DebugActiveProcess is right here, and then it'll do GetDebugEvent, which we don't have, and so it will complain about this. So in our ideal world, it gets to this point. So let's hope that it gets there. Okay, it copied to the SD card. So let's eject this. And then try to run it. Oh yeah, Hecate spews garbage over UART to my Joy-Con because Hecate is trying to communicate with it as though it is a controller, and it is not a controller. Okay, let's see how this goes. Let's see how this goes. Come on, stupid issues. GetDebugEvent was called. Okay, so theoretically we may, keyword may, have implemented all of that correctly. It is not impossible that we implemented all of that correctly. Ooh, that's funny. It's very, very funny. Okay. Cool. Oh man. I'm not sure how to feel about it getting to the point where I said it would get to if it worked. Because that means I don't actually know if it worked. That just means that it didn't fail horribly. So for all we know, there could be like horrible problems in it that we're just not seeing. But, you know. So actually, if we implement this correctly, we are going to have to implement on-finalized synchronization, because on-finalized synchronization is called when a case synchronization object is finalized, as you might have gotten from the name. And the process manager is going to try to close everything in a loop, so we actually will have to do that pretty soon, assuming that, you know, stuff just continues to work and we like implement GetDebugEvent without problems. Which, I mean, we will almost certainly implement it without problems because it is an absurdly simple system call. Like GetDebugEvent, unless I am like really misremembering it, and I mean, I guess we can just check. But like, unless I'm really misremembering it, it literally just gets the debug object from the handle table, and then like clears the event info, and then calls GetDebugEvent info. GetDebugEvent. Yeah. So it gets it from the handle table. Yep. And then it clears it to 0, and then it calls GetDebugEvent info. Then it copies it to the user, which all makes sense. Aurora asks how much of the kernel is left at this point, and there is a very easy way to answer that question. SvcDebugActiveProcess, libraries, mesosphere. There are 136 system calls, although divide that by 2 because that includes both the 64 and 64 from 32 ABIs. So there are 68 system calls remaining to implement. A lot of them are easy though, and I'm sure debugging will take a lot of time. We are way more than 50% done. We are probably like 70% done with the kernel in terms of code. Like we're actually very, very far into getting the kernel done. Like it'll be done this year, especially since it is now my top priority. Also, yeah, it's a microkernel, so there just isn't that much to do. And yeah, okay. Okay. So here's where we're gonna do what's called a pro gamer move in terms of implementing this. SvcGetDebugEvent is one of the SVCs where it has different types for 64-bit and for 32-bit. Here's what we're gonna do. Template. Type name. Info type. Result. Get debug event. K user pointer. Info type. Out info. SvC handle. Debug handle. Then we're gonna do turn get debug event out info debug handle, and this is just gonna be a template function. Yeah, I know, right? It is so rare that these things are actually different. So here's what we want to do. Cool, so that'll get it from the handle table. And we'll return invalid handle if it is null. And then debug event info. Try out info, copy from cool. So that is this is the gamer strategy of having functions that take in different types do the same thing. I mean, I guess templates aren't that much of a gamer move, but this in particular is silly. It's so silly. This will probably have to be two definitions in debug base, unless I want to template it there too. But I think that we probably want it to have two different implementations. Probably. Okay, let's go back to debug base. We're gonna want results. We don't want one taking in 64 and one taking in 32. 64 and I'll output 32. What is the actual type name, which is what I wanted to actually copy paste? Debug info. Okay. Info. Cool. Yeah. Although these will probably be basically the same. I expect. What does this actually do? This gets the process, which makes sense. Process terminated. Okay, this is probably, yeah, locks and then gets a reference to the process. Locks the scheduler, it checks that there is something in the event info queue. If there's not, it'll fall here and it'll return no event, which makes sense. And then it's gonna create an event info. What did I call that type? Event info 64. This is a K event info. Where's out being used here? Okay, so this is basically just popping it. So it's popping it and then releasing the schedule unlock. And then it is populating it based on the info, and then it's freeing the event info back to the slab. So that is actually all reasonably simple. So let's do the thing. Private, we're gonna need getProcess too. However, yeah, getProcess is going to open a reference almost certainly, and this will be closed at the end of scope. Yeah. getProcess, the open will be in here. Yep. Okay. Okay. And then we're going to want public. That's already here. Anything else we're really going to need? Not really, it looks like. Okay. Get debug event info. Okay. First thing this is going to do is it's going to get the process, and if it doesn't get it, it's going to return result process terminated. Okay, and how does this work? This is going to lock the object, it's going to get the process, and it's going to open it. That's really simple. Don't really know why that needs to be its own function, but Nintendo will do Nintendo. Cool. That's a really simple function. Okay. What next? What next? What next? Lock the scheduler and pop an event, which makes sense. Nice, nice turtle. Unless we're empty, we return no events. No worries. No worries at all. So what are we doing? This previous is next. Next prev. Okay, which one is the head? 11 is tail. Tail prev. Tail next. Sure. Okay, I think this is going to be popping from the front of the queue. Yeah, this is popping from the front. Okay. what next? It sets the event to be the event, it sets the thread ID to be the thread ID, and it sets the flags to be the flags. And we're gonna need, he says clicking on the window in the host instead of the guest. Gonna need types common or Chrome64. Now where is this? Man, where did I put this type? Type's base? No. Debug maybe? Yeah, okay, it's in here. Type flags and thread ID is what we're going to be doing. Okay. Type, and I think this is event. Type, thread ID, and flags. Okay. And then what next? We switch on the type, which makes sense. Same thing as usual. And exception is going to have stuff for all of them, of course. Let's do the rest of this now, and then we'll fill out the switch case. This is going to free it, and it's going to decref the process, and I think that should be basically it. Okay, that's a little more debugging friendly. Cool. Okay, let's go copy paste this shit. This is how I always do this. I really shouldn't do it this way, but it's just so much faster. This will probably not be exactly the same, but it's definitely going to have a switch on it, so we'll just do this now, and I will fix it when we get to it. Okay, what happens in the case where we are attaching to the process? It sets the program ID, which is important because that's what we care about. And what is the out field called here? Attach process. And it's program ID. Great. Program ID, process ID. And these are all just named what I would expect them to be. It's going to be out info attach process. Info attach process. Program ID is which process this out? It's just this process, okay. How do I want to do that? That's probably get program ID on kprocess. Cool. Program ID. And then get name, I think, is its own thing. Name, size of out info dot attach process dot name info dot attach process dot process ID process get ID. Is that process flags? I think it is. Okay, just flags. Flags and user context exception address. I went past it. Flags. Let's make this line up already because we don't really need to do this in order. And do I have a getter for flags? Okay, figures. Okay, create process flags. Out info attach process user exception context address. Let's align these. TLS address. Yeah, okay, that'll do. Okay. That's that. Then what about attached thread? Thread ID, TLS address, entry point, which makes sense. Out info attach thread. Thread ID is info. Ready. Then exit process and exit thread both just set the reason, but they're going to be separate anyway. Info.exit process reason is info.exit process.reason. And then exception is going to be the really big one. Okay. How are you doing? I'm doing well. Majosa. Debug events? Yes. I am implementing the stuff that is necessary for Atmosphere to continue booting with the kernel. We're actually getting very far, so I'm very pleased about it. Very, very pleased about it. Did I call it type? Figures. Okay. To switch on the exception type. Reimplementation or a one-to-one copy. What is the difference? Assuming that you are reimplementing things correctly. Okay, I think in this case we only need a couple of them. Undefined instruction, undefined system call, breakpoint, user break, and debugger break. So we want undefined instruction, we want 0, undefined system call is like 8. Breakpoint is going to have its own. User break is going to have its own. Debugger attached. It's not. Debugger break is, and everything else is not. Okay, so these are our 5, and 0. Undefined system call is 8, so it's going to go at the end. Breakpoint is 5. User break is 6. Debugger break is 7. Cool, so these are in order now. Okay. Let's copy stuff. I'm going to have to fix the union stuff on all of this. Exception. Okay. On the bright side, this is all super straightforward. In the undefined instruction case, it's the instruction, but in the undefined system call case, it's the ID. So let's go ahead and do that. Hello, Memeland Clan. Good username. Very good username. Specific dot undefined instruction dot instruction is event, or rather info dot exception data 0, and then this too will be undefined system call dot ID. So it takes care of those two. And then this will be the breakpoint type and the breakpoint address. Let's set this to be user break, the break reason, the address, and then like the size, which makes sense. Let's change this to be the debugger break. And that also makes sense. Okay. This will be out info exception dot specific dot breakpoint dot type info dot exception. Yeah, no, editor and IDA side by side is because the kernel needs stuff to be very, very accurate. Break reason. Let's be static cast. I think it's break reason is what that's called. Yep. Not that the enum has any members. And then the address will be 1, and the size will be 2. I wanted 2. It's a little weird. It's probably because they don't have a good generic way of getting the address. size, great, and then debugger break is just going to be active thread IDs. Great. So let's copy paste this one. Debugger break dot active thread IDs 1. 1 is going to map onto data 1, and we do that for 0 to 3. 0, 1, 2, 3, 0, 1, 2, 3. Cool. Okay, that should be correct, I think. And then let's make our lives happier. I answered this question for Aurora a little earlier, Josa. Oh, I closed the window. But there are 68 system calls left to implement, but a lot of those are small. We are probably like 65 to 70% done with the kernel. We are way more than half done. Like all of the hard stuff, everything that I consider difficult is done. Like as you can see, this is not difficult work that I'm doing right now. It's just, you know, doing the work. Which is fun. But yes, okay. Cool. I think that might be that. Is there anything interesting that's different about it in the 32-bit case? It's probably exactly the same. Yeah. Scheduler shenanigans are known already. There are no scheduler shenanigans left. I mean, if I go to mesosphere source current case scheduler. Scheduler is implemented. There is nothing left in the scheduler. The scheduler is complete. All of the like special yields I implemented recently, like SVC sleep thread just works. The scheduler's done. We are totally good in a scheduler sense. Cool. Yeah, we are mostly winning, Nikki. And yeah, okay. I really need to figure out why mesosphere is not like detecting that stuff needs built, because the GCH file should just work. Like this works and correctly detects clean status in my host. Hey, Kitlif. Man, I really wonder why it's not detecting changes. That's so annoying. So annoying. Because the depend files include the GCH, and the GCH depends on the header. Doesn't it? I like go to libstratosphere, and I look at the make file here. It's so weird. It's very, very weird that it is not detecting that. I mean, I could do... No, because this should include it in the depends. Whatever. It is not horrible to do this. Dude, FS is not bad. I don't know why people are like, oh, we're gonna have such a hard time with FS. FS is simple. FS just has a lot of stuff in it. File system services is not hard to implement, and in fact it is like... The NCA stuff that I did a little bit ago... breakpoint type? Okay. The NCA stuff that I did for Daybreak is all in FS code that can be reused completely directly. I mean, it's not like I'm not just going to use FATFS. Like, I'm not going to write my own... I'm not going to write my own FAT driver. I'm just going to use FATFS. Also, I'm going to let this run for the like 30 seconds that it takes to build the SVC tables, because that's slow and I don't want that to have to restart. Cool. Okay, where are things failing? Out info. Oh, right, okay. That's straightforward. Dude, fuck PR file 2. PR file 2 is so bad. Also, thanks. The main reason to reimplement FS is that it is not reimplemented and it's in firm. Like, I'm gonna be honest, I understand that that's the really like big thing is fixing the exFAT driver, but the reason that I want to do it is because we haven't done it yet. Wasn't the culprit partially how FS handles panics? Yeah, I mean, panics cause issues, but just because they interrupt operations and exFAT doesn't have a backup table, but other drivers manage it fine, and FATFS doesn't have these issues. PRFile is just a dog shit driver. PRFile modifies tables when you do reads. Like, what kind of driver modifies the FAT table when you read data? It's so bad. Yeah, Kitlith, you can get corruption in exFAT using PRFile when you are only doing reads, because PRFile is modifying... No, like, if it was just modifying, like, file time, that would be one thing. But it literally modifies the file allocation table on reads. They use the library because it was written by a Japanese company called ESOL, and ESOL has been providing them PR files since the Wii days. And they're just not going to change away from the FAT driver that they've been using since the Wii. Cool, we built it. Now let's test it again. He says, surprised that things are going this smoothly, because they usually don't go this smoothly. There's Hecate spamming stuff as it tries to use my Joy-Con debug stuff as a controller. If you say is booting, should get Ohio, and then just start spamming stuff. WaitProcessWideKeyAtomic was called. Okay, awesome. Amazingly, do I have a lock or something in the PM code that's doing this? Because it should be calling on finalized synchronization, which isn't implemented. Let me see. That's surprising. Where is PM main? Oh, yeah, this is probably like calling into OS stuff. Have you ever touched the Wi-Fi driver? Yes. Do you think the switch should have been insecure as in like the PS4? NVIDIA not fuck them? Well, for one, the PS4 isn't secure. So no, it wouldn't have been secure like the PS4. It just would have been secure. Like, there would have been glitching for the Switch without NVIDIA fucking the boot ROM. But that would have been it. There would not have been non-glitching attacks. Well, I guess NVIDIA fucked them in general in a lot of ways. Like, the lower firmwares had the NVIDIA exploits. I think probably software hacks would have gotten kernel code execution on low firmwares. And Trust Zone would not have been hacked. And glitching would have been the way that people actually ran custom firmware or whatever. I am very surprised that I noticed that I am surprised that we are getting to WaitProcessWideKeyAtomic. This is inside FS. I wonder, let me turn on process switch logging again. Although I guess this is just calling a register process here. I guess that there's a scheduler lock here, and so it can reschedule to FS at will, and it probably does because FS is going to be higher priority, and FS will like not be waiting anymore. So that makes sense. Okay, I guess we'll just implement it. Condition variable, WaitProcessWideKeyAtomic. So this is just going to be like call getCurrentProcess.wait condition variable, basically. But you know, it pays to do things properly. Let me pull this up in IDA. WaitProcessWideKeyAtomic. This is going to do the like same timeout conversion that it does in other places. I'm just going to call wait condition variable. Yeah. Which absolutely tracks. Let me pull up like address arbiter, I think has this. Yeah, okay. Result wait process wide key atomic. That's going to take in a unit t address, unit t cd key, unit 32t tag, int 64t timeout in s. They generally don't, Nikki. The like one time that they like absolutely have was the random number improvement, but I also like mentioned that publicly. It is difficult to disentangle when they borrow fixes from Atmosphere, and when I say something is a problem in public, and then they fix it incidentally because of that. Okay, so this is going to check if it's a kernel address, and if it's not, return invalid current memory. Yeah. Thank you, Masan. Invalid address. I guess that makes sense. Tag. There we go. Then we want to copy over the timeout conversion logic from this. Their OS is not kind of bad. I don't know why you say their OS is kind of bad. Nintendo does a fantastic job with their OS. Nintendo's OS is like basically rock solid. I totally disagree with the statement their OS is kind of bad, Nikki. Their OS is not kind of bad. Address, aligning down the CV key, the tag, and the timeout. Okay. Address. Tag and timeout. How can you save so much memory? The memory that I am saving is largely just because I write stuff with lower boilerplate because I am not, you know, doing enterprise coding standards. And also because I put a lot of effort into killing the exception table. I think Atmosphere doesn't have R2TI, and I have a bunch of like wrap linker flags that completely kill exception stuff. And that saves like 64K in every process. And when the processes are so small, saving 64K unconditionally just makes you smaller. It's just kind of an unavoidable thing. Our transfer speeds degraded because of... I just Wi-Fi a little, but I don't think I would agree with this statement. Our transfer speeds degraded. My Switch gets totally fine download speed over Wi-Fi. I don't think their driver's horrible. They're using a Broadcom chip, I think. You are probably referring to some specific feeling you have about the way that their driver works. And I have not noticed anything bad about it. It seems like a Wi-Fi driver to me. I don't have opinions about it. It looked like a totally normal Wi-Fi driver to me. Cool, that's already implemented there. What prompted you poking at the cartridge loaded stuff? Nothing prompted me to do that. I have said a lot of times that Lotus is not hacked, and that continues to be true. Lotus is not hacked. What you're asking about is like, I thought of a way to dump stuff from FS memory, and what prompted me to talk about that is it occurred to me, hey, this can be dumped from FS memory. So I mentioned there that this can be dumped from FS memory. It is good to preserve data. But there's nothing deeper there than it occurred to me, and so I shared my thoughts. Okay, condition variable. Well, this is probably mesosphere unimplemented right now. Yeah, okay. Yeah, no, the key area was the only thing that was missing from cartridge dumps. And it's dumpable from memory. So now nothing should be missing, as far as I know. Okay, what is wait condition variable doing? It's timeout address. Remove wait by key, okay. Okay, this should not be too bad, I think. I mean, it's condition variable code, which means it's thread list code, which means it is necessarily pretty bad. But, and this is important, I think it'll be fine. Is there a cancel task in here? I think there's going to be a cancel task in here. This is a scheduler lock. Timeout. Yep, register absolute task. Cancel task. Yeah, okay, this is a scheduler lock and sleep. So let's get started. So the first thing this does is get the current thread. Yeah, I mean, if you want to pick my brain, Nikki, we're friends. You can just send me a message on Discord. Like, it's not like you can't just ask me a question, and I will generally respond. K-process. What happened to the Pokemon model import shit? I mean, I said then, when I was doing that I was just interested in creating tools and not interested in actually doing all of that work. And that's what I did. I handed over all of my notes to this guy, MVIT, who is awesome and does really good work. And I have left the actual work to the people who are interested in putting in the hundreds of hours that will be required to it. All of my notes and all of my tooling has been shared with the relevant people. Let me pull up the address arbiter code, just in case there is structural similarity here that I can use. Yeah, okay. There's absolutely going to be structural similarity here. What does this do? This checks whether or not termination has been requested, which is exactly what this does. And it clears the synced object first, which is interesting that it does that before, whereas an address arbiter wait if less than, it does that afterwards. Yeah, basically what Majosa said, except not sarcastically. Object. Cool. And then here's where it's going to be all different. Okay. We want to remove waiter by key. Where this A2? This is like memwait. I don't know why that's called A2. Are you going to hack Pokemon Sleep? Of course. With my sleep being how it is, how could I not hack Pokemon Sleep? What a great meme. This is cur thread, but it's also like the owner thread. That's fine. Owner thread just gets the value. Sure. Just copies it out to user. Sure. Then this will like set the condition variable. Sure. This will insert it into the tree. Sure. And then if the timeout is not 0, it'll register as waiting. Okay, that's fine. That is fine. Okay. Hey, Wiggy. Address of waiters. Address. What does this do? This is really like the next value. Okay, what do I call the thing that gets the arbiter value? Address key value. Okay. Address key value. Where's like all the arbiter logic? That should be in here somewhere. Address arbiter key. Yeah, okay. Trying to mess with some 3DS hacking on a game that uses a scripting engine. Scripts are freely modifiable. That is cool. That is fun. 690. Let's look at what that's actually after, because I probably used a different name. Okay, thread. 690 is the arbiter value, so it'll be before suspend requested. Flagged. Address key value. Okay. Yeah, makes sense. Get address key value. Okay. Is next owner thread. Get address key value. If waiters is if there's more than one waiter, we added the handle wait mask. And then is there anything else done here? Okay, and then we want to write the value to user space. So how do I do that? Write to user. Great, I already have that. And of course this logic was already here, ready for me to copy paste it. That's hilarious. I love me doing the same work multiple times. It's fine. Whatever. It's not exactly the same anyway. Cool, we write to user space the address and the next value. This is not a thing here, but it does, yeah, okay, it's gonna cancel the sleep. Okay. And then this is gonna set the condition variable. Okay. Cool. Just gonna return result success down here. There's more stuff, but I'll get to that. And then the next thing it's gonna do is update for the condition variable. Thread set variable. How do I do this in the arbiter case where I did set address arbiter? Address of tree. And then it is also going to set the address, the CV key, and the tag. Address, CV key, and value. And then it's going to insert it into the list. Cool. Then we can just skip past all of this bullshit. If the timeout is not 0, set the thread as waiting. And then more stuff will happen here. Do I have anything in here already? Cancel task. No, but I bet I do an address arbiter. Cancel the timer wait. And so the way that this will work is this will sleep until stuff is done here, which means that after this scope, we are done waiting, which is nice. And then what does it do after that? So this register absolute task is in like the destructor of scoped schedule unlock. So okay, here we are. If timer, cancel the task, and now we're here. So it unlocks the scheduler again, and then it gets the unlock owner. And if it is not null, then it removes it as a waiter, which makes sense. And then if it is waiting for a condition variable or an address arbiter, which is to say this is non-zero, then it removes it from the list and it clears the condition variable, which makes sense. Okay, then does it do anything else interesting? No, it just returns get wait result. Okay. So let's mostly copy this. Variable. This is the same code, but whatever. Do I use that elsewhere here? Okay. The only other thing here that it's doing that I mentioned is it removes the waiter if it has a lock owner. So if a thread here is cur thread get that. Do I already have something for that? Get lock owner. Great. Cool. I think that should be correct, except all I need to add is waiting for condition variable. I need to clear condition variable, and I'll need to add set condition variable. Condition variable. Why no VS Code? I prefer Notepad++. I don't really use IDEs. Void condition variable. What are the arguments to this again? Address, key, and value. And this just sets the stuff. Why on earth do I have a field called arbiter key and a field called convar key? What is wrong with me? I mean, CV key is clearly going to be CV key, but address arbiter, wait if less than. What is wrong with me? Convar key, yeah, okay. That's, fuck me, why did I call it that? Convar key, address key. Okay, I think that address key is going to be address, probably. Yeah, okay. It's address key and address key value. I don't know why I called it arbiter. It's not used by arbiters. Address key, address, this address key value is value. Okay. What is wrong with my past self? Is CV key. Okay. Is there anything else that I need to add here? Set condition variable, we're good. Is waiting for condition variable, I need it. Great. Okay, is that going to compile? It might. Oh, so now it's compiling? Now it's not complaining? I swear. I swear, I swear. Address is not here. Okay, that's going to be get integer address. Or rather, this is just going to take in a K process address. And the other thing is going to have to be a get integer adder. Waiter by key, which this compares the arbiter key. Let's just double check that I implemented that right. I need to stop clicking on folder in the host. But, waiter by key, get address key. Okay, yes, that's fine. Okay, why is it complaining now? Wait, process WideKeyAtomic. Okay, that's... I always do that. Of course, of course, of course. Let me, while I'm at it, connect my switch to the host so that we can copy it over once it's built. I'm really glad that the kernel takes like 30 seconds to link, because it gives me a lot of leeway in terms of when I have to set up Hecate to do the UMS. And I'm not happy that it takes 30 seconds to link, but like it taking 30 seconds to link is to my advantage, and that I always forget to connect my SD card before I start building it. But yeah, no, okay. we might have just finished implementing WaitProcessWideKeyAtomic, which is nice. That's exciting. It's process wide key, as in a. The wide is a part of process wide, not wide key. And so that's just a way of saying that it's an atomic wait on some key, which refers to the convar address. It's just a weird saying. It's just a weird way of saying wait on condition variable. Cool. We are running Fuse now, and let's see how it goes. Okay. It's doing stuff, but it hasn't panicked. I wonder if it has gotten into some kind of infinite loop, which isn't impossible. I'll probably need to add a logging to figure out what it's doing. It's not showing anything on the screen, so there's some kind of issue. But this is the kind of thing that's just gonna need logging. Well, let's add the stupid log, which I have commented out right now, so we can at least see if any activity is happening. Cool. This is probably going to require debugging off stream, although I'll give it some effort here. Is my prediction now. Just because this, I'm probably gonna need to like set it up to run an emulator to see where things are going wrong. Unless I just add like input to all system calls for logging, which would be really obnoxious. I might need to like add an interrupt thread that just runs after 5 seconds and like outputs what each core is doing. I mean, all cores other than 3 should be asleep because they have nothing scheduled to them that early in boot. But you never know. You never know. On the bright side, the fact that it is not hitting a panic means that this is the farthest that this has ever gotten, which is very exciting to me, at least. I am very, very happy to see it getting that far. It's awesome. It's really, really cool. What weird symbols? What are you asking about, Majosa? Oh, that's not from my kernel. I restarted and connected it in Hecate, and Hecate tries to use my Joy-Con as an actual Joy-Con and not a UART debug port, and so this isn't like sending touch data, or not touch data, analog stick data, and trying to interpret that as characters. That's just Hecate being Hecate. Okay. Let's run this again, except now we will get a log on every process switch. Interesting. Okay. Interesting. That's actually positive. I don't know why it is error scheduling the null process, but what this tells me is oh, I guess every process might be waiting on something, like FS might be waiting on an interrupt event. That is good to see. Okay. Because that is something that I can work on debugging wise. Kern K interrupt task manager. Unqueue. And let's look at the backtrace for this. Atmosphere, mesosphere, kernel. Okay. 1p-ECC. Yeah, okay, that makes sense, but what is calling it? It's an handle interrupt, and what do you want to bet that handle interrupt doesn't actually call this directly again? Because I had another issue like this the other day. Handle interrupt, actually, interrupt, task manager, unqueue task, on handle interrupt. So if it is, if the interrupt task is not the dummy one, it unqueues it. Does that make sense? Okay. Let's see where this is happening. Task manager. Is this one of these? Yeah, I'm gonna have to go to architectural code. ARC-64. Current interrupt manager. Handle interrupt. On handle interrupt. Okay. If task is not get dummy interrupt task. Okay. Task is the entry handler on interrupt, which also makes sense. Oh, no, wait, that's going to be just the K interrupt task, which is going to return itself. That actually, I think, is correct here. So the real question is why it is returning an interrupt task that is already got a next task. Because I don't think it should be possible to have an interrupt occur for a task that is in the queue. Like this locks the global interrupt lock. Although, am I not doing that? If it's local, get local interrupt entry. It looks like this is all happening while the local interrupt lock is held, and I don't know if I'm doing that, which would be a stupid reason for this to occur, but could exploit it pretty handily. Let's see, get local interrupt entry. Okay, so that's probably in the header. Ugh, sorry about that. I accidentally clicked on the VM in a way that made it really huge. Now let me fix that. Fix that again. Just a little more, I think. Sorry about that. It's good enough. It looks like it's better on the stream now. So let's assume that it's close to 1080. Okay. mesosphere. Include mesosphere. Oh, is there? Let me fix that. A little further. Okay, that's better. Right, Gitlith? Cool. Interrupt entry. Okay, well, I think I see why things are sad. Since we need to be locking stuff and we are not locking stuff. That's very funny. Oh no, wait, we do lock it for the global case. Never mind. Okay, we lock it, we get the entry. It's manually cleared, we disable the interrupt. We set needs clear. And we call on interrupt. What about in the local case? In the local case, we set the priority level, but we don't disable it. We set needs clear 1, and we do on interrupt. Okay, interrupt task manager. Thank you. Set next task. Tail is task. Yep. Head tail. This head is get next task. Okay, where does deck actually happen? Task do task. Oh, I bet that this needs something else. Node function. Task is no pointer. Set is waiting. Deck. You had do task. Where does next task actually get cleared? Because that's going to need to happen, and I'm not sure immediately where the code responsible for clearing the next task is. Oh, right, this is like an assertion. This is an assertion, okay. So I think this is literally just the assertion being bad because we're not clearing it. You prefer verify code accuracy before you even touch a debugger. What do you mean touch a debugger? What debugger would I use? What? Like this is running on hardware. I don't have a debugger. Yeah. Get dummy interrupt task. Yeah, I have printf debugging. Kern K interrupt task. Okay. So let's do this here. I do prefer printf debugging. But actually there's no bot there. I do prefer printf debugging. But yeah, no, I mean, verify code accuracy before using a debugger is just like, yeah, I mean, correct. And then deck, we want to to do here. Will people debug by checking whether or not the backlight is turned on? God, that is such a fucking classic. I love it. Okay. That should fix that. Like, this assertion, I think, is literally just the assertion isn't right. But whether or not it is, this should all be happier now. Oh, and of course, that time it builds without having like cleaning issues. Why does it sometimes work and sometimes doesn't? It always works on the host. Backlight is a lot easier to turn on than it is to like actually render colors, Majosa. Okay. We are gonna run it with this now. Yeah, I guess that this would have aborted whenever an interrupt task was run twice. And now, whenever we're auditing, we will be fine. Debugging shaders using color. That is probably the correct way to debug shaders. Actually, also, let me not be stupid. I mean, I'm always stupid, but in this particular case, mesosphere audit is in fact a shorthand for what I wanted to do here. Nice. And of course it doesn't detect the changes that time. Totally classic as always. Fuck, that's so annoying. Whatever, doesn't matter. Okay, now let's run it. I wonder if the hang forever was it just not getting all of the UART output. That happens sometimes. That actually does sound significantly more likely to me. Why is it asserting that still? Next task is null pointer. Set next task. Hold head, set next task. Null. Get head. Whenever it successfully dequeues a task, it should clear its null pointer. Am I like imagining that? Let me pull up the new kernel and I wonder if this is another one of those make clean issues where I like need to do the make clean. That would be a hassle. Let's give it a second to process. I'm gonna try and make clean if this doesn't work, just because I suspect this is a building clean issue. What a total hassle. assert that it's getDummy task. If it's not 1, sure. I1 is 0. Sure. Head next task, sure. That should be correct, I think. But then I don't understand how the task can be enqueued twice while it's already in there. Is it really enqueuing a task that is already in the queue? That sounds distinctly not like correct behavior. I mean, I can believe it, but I don't think that's right. Let's dispatch. Let me look at this again. Thread loop, yes. Okay, so I think the conclusion here, since it did build, is that it is enqueuing an interrupt task that it is already enqueued. That is like currently in the queue, and so the task is ending up in the queue twice, which really shouldn't occur. Really shouldn't occur. Because it shouldn't be possible for the interrupt to happen while it is like a task that needs to be run. I'm going to keep this stuff because I think that this is good, and I'm glad that we changed this because this was a problem, at least before. Oh wait, if this head is this tail? Oh, okay. I see. No, actually, this was just not right. There we are. There we are. That would explain it. That would explain it. Okay, so that would explain why that didn't solve it, is because in the case where the interrupt task was the only thing in the queue, we still would not clear it. And so that explains that. Does Windows not have an equivalent to pushd? I don't know what pushd is, so I can't answer that question. I suppose I would ask, what is pushd? I don't think it has a stack of directories. If it is, I don't know how to use it. And that's one of those things where I suspect you are correct about it being a thing, but I don't know how to do it. Okay, that makes sense. I just have no idea how that works, if that's a thing. Ooh, also it's linking, and I forgot to put it on UMS, so let me do that. I sure am glad that it takes forever to link the kernel. It's very funny that that worked. Cool. Cool. And then let's checked. And run it. Okay, that should fix that assert at least. Well, it's definitely doing a lot more stuff now. And it looks like it is scheduling the idle thread, which it probably should not be doing. No, there's more stuff. There's more stuff. That's almost definitely it waiting on interrupt events. So I bet there's a problem with my interrupt events. Let me comment this out. It's probably not really needed. Okay, so I'm gonna assume that this is it like forever waiting on an interrupt event when it shouldn't be. Fascinating how stuff is getting so far. This is really cool to see though. That's very, very cool to see. I don't think UART output is getting lost again because it is like continuing to do process switches. And if it had panicked Kitlif, then it wouldn't be continuing to run the scheduler because panic is an infinite loop that stops the scheduler. What is happening here? Yes. Loader is running and loader is doing its setup. Process manager is running and doing its setup. NCM is running and doing its setup. Yeah, no, it was continuing to log process switches. Okay. I think what I am probably going to need to do is I'm going to need to like add calls to wait synchronization. Because this is definitely, these loops, every other process is waiting on stuff. And file system is going to be like waiting on some interrupt event to occur. That is definitely going to be the problem. Let's see, how did I implement the interrupt event stuff? Because I bet that's it. Because the only interrupts that this stuff can wait on are these. Interrupt, do task. Let's add some quick and easy logging. Log. Process get name, and then this will be okay. Let's build that and see what it says. As always, my suspicion is just going to be that we're going to have to debug a lot of this off stream. It's been like 3.5 hours anyway. Because interrupt stuff is just eldritch. But I will give it an honest shot. Let me connect to my switch to the PC so those will copy correctly. Does anyone have any questions about the debugging stuff or anything else about the kernel / what I have done today? Because while we have downtime while stuff is building, I am happy to answer questions. Isn't a better way to load new binary than put SD on computer? I have no idea what you mean. How would I do this a better way? I mean, I have no idea how I would do this a better way, so I'm going to guess that there is not at least an obvious way to do it better. I did implement resetting, I think. I thought that worked. Loading the kernel over USB somehow. Given that Atmosphere itself is loaded off of the SD card, the kernel kind of has to be loaded off the SD card. Still don't think it actually helps us much. So FS is it waiting for some interrupt that's not getting signaled? I mean, we are seeing interrupts signaled, like I saw one up here, maybe. Yeah, signaling interrupt event for 63, which makes sense. However, it looks like FS is waiting for some interrupts, and that's not getting signaled, maybe? Oh no, never mind, there it is. I wonder what all the other processes are doing. Because they shouldn't all be waiting like that. And if something was going wrong, the processor should be aborting. But they must all be waiting somehow, which probably means I'm returning like a bad result code or something. So, here, let me turn this off so that it stops sending events infinitely. So at this stage in boot, Process Manager has registered itself with SM. It's like gotten stuff. I think Process Manager should be registering stuff with FS. I mean, there's one easy way to test this, which is to say, you know, do the stupid thing. Let's hear Stratosphere PM. Let me cd Stratosphere. Make J16. Then I'm gonna do that while I do this, so it'll build while I'm making edits. Source main. One thing that we can do here, since we have actual output, is we can do what is this complaining about? Right, okay. Okay, be honest, start. Use a printf. Log buff, size of log buff, SVL, NVL, output, debug string. This is going to have an out of bounds right, but I don't care. It's fine. Yeah, I mean, I guess you're right about that. I guess you're totally right about that. Cool. Cool. If it gets to this point, it'll be fully running, but it's probably getting stuck somewhere in here. Let's add that here, though, just in case. Cool. Lab Stratosphere is built just as we were getting ready to do this anyway. Typo. Inverted argument order. Cool. And let me connect this again. Yeah, that's fine. Cool. Should be good. Okay. Now let's run it. If that doesn't work, I'll probably add logs in there. Looks like it's not getting all the output, so let's restart it. That looks like it's missing a lot of output. Okay, running it again. I don't even know if it got the Ohio there. We are logging over Bluetooth, and so stuff just kind of gets spuriously lost sometimes. It depends on the strength of the Bluetooth connection. Okay, initialize PM, initialize FSPR, initialize SM Manager. And then it is never finishing registering the processes. Okay, great. That tells us rather a lot about where things are getting stuck. That means it's getting stuck in here, which is great to know. Because now we can add a bunch of logging. Also, I'm going to remove the process switch statements because they are annoying. Actually, they're fine. I don't need to remove them right now. But okay, so we are getting stuck in there, which makes some semblance of sense, actually. Also, the fact that I can debug the actual system modules themselves this way is so nice. Like, it is ridiculous how nice this is. Wow, okay. Processes. Yes, this is a jailbroken switch. Pipig Warrior. I am developing for the switch's custom firmware. I'm the guy who does that. It is not, but that is just the creator wanting to clean it up. If you have any interest in using it, HDSH just contact Deer. He has shared it with everyone who has asked for it, so far as I know. Awesome, okay. I agree, Deer is brilliant. Okay. Okay, I think that should be all of the logging we could possibly want here. Extra paren in both cases. Yeah. SD card. Yeah, okay. Cool. I am very happy to know that the issue is somewhere in here, because this just means like PM is waiting forever. When it shouldn't be. That's like substantially easier to debug than other crazy stuff. Okay, let's run that. Okay, so let's analyze this log. It looks like PM is trying to register the process what is 01004? Let me actually look this up. Title list. So it is registering SM with itself. Oh, you know what I think is going on? And actually, I bet this is what's going on. Let me check the processes it's registered so far. This is definitely going to be a problem. Wow. Okay. Where's it going to be? Getting program ID for. I really need a way to grep this output. So the first thing it registers is itself, which is interesting. But I guess, yeah, it's the first kip, because it is on the SD card. And the next thing it does is it gets the program ID and it gets 1, which is loader. I know exactly why this is hanging. Okay. It gets the process ID for loader, it registers it. It gets the process ID for... okay, it only actually does loader before it does SM. Okay, so here's why it's hanging. As I mentioned, we have not implemented on finalized synchronization for KDebug. And the debug objects that we are opening is not being closed properly. Probably there's like an extra reference to it dangling somewhere. But the reason we are dangling a reference to KDebug somewhere. And so KDebug is not being closed, which means that we are debugging SM and trying to register ourselves with the debugged SM, which means we wait forever because SM can't run because it's being debugged. And close handle will be called on the debug handle by this. This works under the normal kernel. So probably we need like some overridden finalize function on it. Super interesting. Totally explains what we're seeing. Great. Let me confirm this, which shouldn't be hard. This is going to be like even more spam, but whatever. Mesosphere. Auto object. But yeah, no, that's why it's hanging. That's exactly why it's hanging. I had code for this that I sent in the host somewhere, so let me do... I'm searching in my DMs in the host. Yep, okay, there it is. Mesosphere log. Open. Mesosphere log. Close. Okay, so this will tell us when we're opening, when we're closing, and what the reference counts are. Let me do this. which is good. Okay. Close the PM because that should be fine. And oh, the reason that we got different output once we started debugging like KIPs is because it changed the process order too, which explains a lot. I'm really glad when things make sense. Yeah, no, we are all glad when things make sense. Okay, awesome. Reference count leak makes way more sense. Or maybe not even a reference count leak. Maybe it's just not calling on finalize synchronization on finalize. Let me actually check that. Did I actually hook that up? I bet I didn't. I might have, but you know. Kernel. I want libraries lib mesosphere. Okay, synchronization object. It will be. No, it does call on finalize synchronization object. Okay. So it must be reference count leak. But yeah, no, the issue is literally just that it's not being closed. And so we are trying to register stuff with a in the middle of being debugged service manager. The fact that I can actually output stuff from Atmosphere processes is so nice. I mean, every process other than FS is mine at this point. So we can debug issues in any process. That is super convenient. It's absurd. It is absurd how much stuff I've re-implemented over the last 2 years. And I'm happy with the way things have gone, but it's funny. Building SVC tables, which takes like 30 seconds. Cool. Let's do this now. Nice. You may not like it, but this is peak debugging that you're seeing right now. What a joke. There's so much fucking stuff happening. Jesus. Great. Yep, that would be it. It's opening the session request in order to do IPC. Okay, cool. Let's turn this off so we stop getting spammed, because we can see here where things are going wrong. Okay, this is going to be DebugActiveProcess. It goes from 1 reference to 2, and then it closes it. Let's go fix it. So that's confusing. Where is this extra reference coming from? Okay, debug base. SvcDebug. Oh, I bet I know what it is actually. because we are creating it as an auto object, but create initializes the reference count to 1, and okay, yeah, it's fine. I know what it is. Yeah, okay. Let me just quickly find all bugs of this type. Yeah. Okay. There's the problem. Is I can't create an auto object here because an auto object conversion from raw pointer to auto object does an implicit open. But create will initialize the reference count to 1 already. So this just needs to be kdebug. Debug unless debug is not a pointer. On scope exit debug close. Okay. We do that in like the couple places where that's a problem. Just space unless dash is pointer on scope exit dash close. What next? Interrupt event and thread. Okay. Thread reference leaks. Nice. Is there one interrupt event? Maybe I could probably do create scoped, but I'm fine with this. Like this is fine to me. I don't need to use scoped auto objects literally everywhere. I'll look at doing that later. Close, and of course then I'm gonna need to just replace get pointer unsafe with event. I'm gonna need to do that in the other places too. Thread get pointer unsafe should just be thread. Should just be thread, and this should just be thread. Let's fix it for the DAS too. And let's fix it for debug event. Cool. That explained that. Should have noticed that I was confused when I didn't see on finalize synchronization called, because I should have. Okay. Yep. Cool, that should fix that. We will let that build now, and I will connect this to the SD card. Also, I'm going to turn on a lamp. Turned on. Hey, StockPixel. You are coming in right at the end here. But it's good to see you regardless. There's probably maybe like another 5-10 minutes left in this stream. But I would like to verify that it gets to on finalize synchronization object with that fix, because it should. Yeah, okay, this explains it. There's an open here when there shouldn't be. No worries. There's always the VOD, and I will be streaming more. I have time again. Yeah, you can see the interrupt events here are going from 2 to 3 instead of 1 to 2. So those are also wrong. Cool, well I'm glad we're figuring this out now. Me, I will probably have to debug this off stream. Okay, pass me. Cool, it's built. Let's run it. I'm not sure, do you guys hear the like USB device plugged in notification that I get whenever I plug in the device? Like whenever I connect and disconnect to my Switch, there's like a USB sound played by Windows, and I'm not sure if that's captured for the stream audio. Oh well, not like you guys really need it. Cool. If we did this right, then I expect / hope to see a panic statement. I love watching SPL initialize all the FS initialize all the NCA keys with SPL. That's what's happening right there. But if all goes well, we should get a panic because I didn't implement KDebug on finalized synchronization. It's a lot of IPC that's happening. Yep, there it is. Awesome. Okay. So that totally explains it. That was the issue. We found it. Okay, let me remove the prints from auto objects since those aren't necessary anymore and they are ridiculously spammy. We did Reddit. Something like that. Something like that. Okay. It has been about 4 hours, and this function is big, so I'm not going to try to implement this right now. What I will do is I will do git status, git add, please, mesosphere, git diff staged. Let's just check if there's anything crazy in here. Okay, Bachosa. I'm just going to commit this, and then it'll basically be the end of the stream. I'm just making sure that I didn't include any super egregious debug commentary. Interrupt event stuff. There it is. I knew I would forget something. It does not. Killeth. Cool. Cool. It's been 4 hours. I have had a lot of fun here. This was a lot more productive than streams where I've had guests, as much as I do like having guests. Is there anything anyone would like to ask before I call it a night? I have had a lot of fun doing this. Will you be doing more kernel streams soon? Yes, I will. I will be doing more kernel streams soon. I will absolutely be doing more of these soon. No problem. I'm glad that you enjoyed it, HTHH. And I hope that you are glad that there is finally a reviewable IPC code, since I know that you and Masan were really interested in the details of that for a long time. And IPC seems to just be working, so far as I can tell. I mean, I'm sure there are subtle bugs in it because I don't do things correctly. But yeah, I'm really glad that the IPC code is in and seems to be working. Thanks. I'm happy about it too. Cool. It is 8 p.m. my time. No problem, Ren, Amamiya. I'm going to go make dinner, or well, not make dinner. Dinner's probably already been made for me, knowing the state of things. I will go eat dinner rather, and I will be on reswitched for the rest of the night. Although probably not working on kernel stuff. I will probably be not super productive for the rest of the night. Cool. Have a good one.